In this video, we will look at word problems involving two types of subtraction. Comparing two fractional amounts to find their difference, or taking one amount away from another to find their difference. Both of these types of subtraction occur commonly in solving word problems. Let's begin with a word problem that uses the comparison concept to determine the difference between two amounts. Taylor has 5/6 of a bottle of maple syrup in one bottle, represented by this bar, and 3/6 of a bottle of maple syrup in another, represented by this bar. What is the difference in the two amounts of syrup? Well, we can compare the two differences and see that it's 2 parts out of 6. So we have 5/6 minus 3/6 equals 2/6. So the difference in the amounts of maple syrup is 2/6, or we could write 1/3 of a bottle. Next, let's illustrate the takeaway concept of subtraction. If Taylor has 5/6 of a bottle of maple syrup, represented by this bar, and uses 3/6 for making cookies, what fraction of a bottle of syrup is left? Now we only need one bar in this case. We'll represent the solution by crossing out or taking away or using 3/6, so I'll cross those out. And we have 5/6 minus 3/6. We have 2/6 remaining. 2/6 of a bottle. These examples show two different uses of subtraction. In the first example, we compared two amounts, so we needed two different bars, one for each amount. This is called the comparison concept. In the second example, we only needed one bar, we only had one amount, and we took part of that away, and this is the takeaway concept of subtraction. These two examples also show that when subtracting two fractions with the same denominator, we only need to subtract their numerators and keep the denominator. By the way, if you use a water-based pen to cross out the parts of a bar, these marks can be removed as good as new. Let's look at another example of subtracting fractions. If a chemistry kit has 2/3 ounce of calcium sulfate in one test tube, represented by this bar, in another test tube there's 1/4 ounce of calcium sulfate, what is the difference in these two amounts? We have 2/3 minus 1/4, and we can see that that difference is a little bit more than 1/3. So we can find the difference by replacing these two bars by bars that have the same size part. We replace the 2/3 bar by a bar having 8 parts shaded out of 12, and the 1/4 bar by 3 parts out of 12. So we replace these two bars, and now we've got 8 twelves minus 3 twelves. And we can see the difference now is going to be 5 twelves. So we've got 5/12 ounce of calcium sulfate. So this is another use of the comparison concept of subtraction. Let's look at a similar word problem that involves the takeaway concept. If a chemistry kit has 2/3 ounce of calcium sulfate, represented by this bar, and 1/4 ounce of calcium sulfate is used for an experiment, what fraction of an ounce of calcium sulfate will be left? So we have 2/3 minus 1/4. Now the common denominator for 2/3 and 1/4 is 12. So we've replaced the 2/3 bar by an 8/12 bar, and then we want to remove 1/4, which is 3/12. So we'll remove or take away 3 parts, and we have left 5/12. So 2/3 minus 1/4 is 8/12 minus 3/12, and that's 5/12. 5/12 ounce. So we have 5/12 of an ounce of calcium sulfate left. By looking at two examples like these, where in one case we compare two amounts, and in the other case we take one amount from another, we can see the difference in the comparison and the takeaway uses of subtraction. Let's finish this lesson by looking at the complement of a fraction. 3 parts out of 5 are shaded for this bar. The fraction for this bar is 3/5. The fraction for the unshaded part is 2/5. Now the unshaded amount is the part that's missing from completing a whole bar. So the fraction for this amount, 2/5, is called the complement of 3/5. So we can write 3/5 has complement 2/5. The complement is useful when subtracting a proper fraction from a whole number. 1 minus 3/10 can be illustrated by a whole bar for tenths, and we want to take away 3/10, so we can cross off 3 parts out of 10. 1 minus 3/10 is 7/10. 7/10 is a complement of 3/10, and together 7/10 and 3/10 complete a whole bar. Suppose we had 8 minus 3/5. Now the complement of 3/5 is 2/5, so 8 minus 3/5 is going to be 7 and 2/5. Or we could think of 8 as 7 plus 1. Subtracting 3/5 from 1 gives 2/5, and we have 7 and 2/5. In the next lesson, we will see that the idea of complement is very useful. Whether solving problems that involve comparing two amounts to determine their difference, or taking one amount away from another, the computation or algorithm looks the same, whether it is written as a horizontal equation or written in vertical form, as shown here. However, modeling both the comparison and takeaway concepts of subtraction can help students understand subtraction algorithms, as well as help in recognizing the need for the operation of subtraction when solving word problems. On FractionBars.com, the game Rope Tug involves subtraction of fractions with like and unlike denominators. For this game, we will click Start, select a difficulty level of 2 in one player, select a character and type the name, and click Continue. It's a good card for Diana. Diana's looking very good at this point. Now somebody is going to get pulled into the pit, and it may be the robot. At difficulty level 3, the fractions for this game have different denominators.